2. And today we will converge with these left out in unit 4, that is Runge-Kutta method and Euler's method. Under the Euler, we need to visit with the modified and improved Euler method. Along with we have to visit with some statistical techniques. And see, this is what the yesterday's problem. I think, hope you solved this problem. There won't be any deviation from the given answer. What the answer for point 1 and point 2. When x is 0.1 and 0.2, the y is 2.205517 and 2.42139. And this is what exercise number 3. I'll rush up with these slides. You try to listen the content. After completion of these things, I'll circulate this PPT. You practice one by one, and you try to familiar with these contents. And this is what using Runge-Kutta method of fourth order solve for y at x is equal to 1.2 and 1.4 from dy by dx is equal to 2xy plus e power x divided by x square plus x ex with x naught and y naught as 1 and 0. See, what we need to do, we need to begin with the initial boundary condition, and we need to find the interval. The interval can be found with the given limit and the required question. And see here, the 1.2 and 1.4, this is what we need to find. And with the initial value as 1, we can find the interval that is 0.2 is an interval. And we'll try to crack with x is equal to 1.2. Then we'll try to find the value when x is equal to 1.4. And in order to find the y of 1.2, we need to, that is for the very conscious that the second order, third order, and fourth order, these Runge-Kutta method has the unique formulas. Apply the respective formulas to find the respective answers. Here the k1 is equal to h into f of x naught y naught. Right? We have to apply the x naught y naught values, and we need to try to find the values of the k1 and k2 and the rest. Through that we can find the delta y. Once the delta y is known, then we can accumulate with the y in order to get the newer y1, that is newer y or y1. And while applying x as 1 and x naught as 1 and y naught as 0, this is what k1, that is 0.1462. And when we are applying the values with k2, the k2 is equal to h into f of x naught plus h by 2 comma y naught plus k1 by 2. And while applying these values, we will get k2 as 0.14004. And this is what for k3. And 0.13991. This is what k4, 0.134809. So the delta y naught is equal to 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. And this is what the delta y, 0.14015. And this has to be accumulated with y. Therefore, y1 is equal to y is 0. So there won't be any change, and y1 is equal to 0.14015. And in similar fashion, we need to find the value y of 1.4. Our k1 is equal to 0.134822 and k2 is equal to 13012. And k4 as 12601, and delta y1 is equal to 130.13028, and our y2 is equal to 0.27043. And you make as a table. If if the required value is only 1, then leave it. If there are more than 1, you make a table and present with the table. This is what the required table. And in basic Runge-Kutta method, we solved 3 different problems, and this is for simultaneous differential equation. See, the equations, when we are dealing with simultaneous differential equation, it has to be solved with some other set of formulas. That is what presented here, k1, k2, k3 and k4. And this is what easily you can remember these formulas when compared to the earlier, the conventional Runge-Kutta method. The simultaneous differential equation is you can easily remember these formulas. Here K1 is f h into f of x naught y naught z naught. Similarly, L1 is g of x naught y naught and z naught. And K1 similarly K1 K2 K3. Here L2 L3 and L4. This is not K3. This is L4. So delta y is equal to 1 by 6 to K 1 by 6 into K1 plus 2K2 plus 2K3 plus K4. Delta z is equal to 1 by 6 to 6 into L1 plus 2L2 plus 2L3 plus L4, and we are going to find the value of y1 and z1. And this is what the first problem, using Runge-Kutta method, tabulate the solution of the system dy by dx is equal to x plus z and dz by dx. See, this is not the conventional technique where we are dealing with simultaneous equations. So we need to depend the above formulas in order to find the y1 and z1. When y is equal to 0, z is equal to 1. When x is equal to 0 at intervals for h is equal to 0.1 from x is equal to 0 to x is equal to 0.2. And yes, f of x, y, z is equal to x plus z, and g of x comma y is y comma z is equal to x minus y, and we need to find the various k and l, and then delta y and delta z and r y1 and z1. See, now to compute 0.1 and z of 0.1, k1, find your k1, apply the values, respective values, and k2 and l1, l2. See, here L1 is 0 and L2 is also 0, and K1 is equal to 0.1 and K2 is equal to 0.105, and K3 is also 0.105, and K4 has 0.10997 and L3 is equal to minus 2.5 into 10 power minus 4, and L4 has minus 5 into 10 power minus 4. And see, this is what delta y. Delta y, K1 1 by 6 into K1 plus 2K2 plus 2K3 plus K4. 0.104996, and delta z is equal to minus 1.667 into 10 power minus 4. So our y1 is equal to 0.104996 and z1 is equal to 0.9998. Similarly, you have to find the value of y of 0.2 and y of z of 0.2. Usually I'll give the questions. You have options. While inquiring with this problem, it will take around 20 to 30 minutes. And for spending 20 or 30 minutes for a single problem is very hard. So you attend some other problem in order to get attend in a shorter time. You attend some other problem, and see, this is what K2, L2, K3 and L3, K4, and our Y2 is equal to 0.2199 and Z2 is equal to 0.9984, and this is what the results. And exercise number 5, solve the simultaneous differential equation. Dy by dx is equal to 2y plus z, and dz by dx is equal to y minus 3z, and the limits y of 0 is equal to 0, y of z of 0 is equal to 0.5 for y of 0.1 and y z of 0.1 using Runge-Kutta method of fourth order. And that's all about the Newton-Raphson Runge-Kutta method, simultaneous differential equation. Any clarification in simultaneous linear differential equation? Any doubts?
No, sir.
Yes. Okay. The next topic, the basic information about that statistics and linear regressions, and see, for that we need to understand about the statistics, and the statistics is a way to get the information from the data. We are trying to get the information through the data. That is what statistics. And the information which is usually a knowledge communicated concerning some particular fact, for that we need some data, that is fact, especially numerical facts collected together for reference or information. The conversion of the data into information is nothing but statistics. And see, it is a tool for creating new understanding from the set of numbers or set of information or set of facts or whatever it might be. And see, we need to understand about the population and sample. These are the technical terminologies or nomenclature related to linear regressions. And concerning statistics, it is in science of collecting, describing, and interpreting the data. There are two classifications. One is descriptive, the other one is inferential. The collection, presentation, and description classified as descriptive statistics, and making decision and drawing conclusion about population is nothing but inferential statistics. And see, population is the group of all items of interest to the statistic practitioner. That is what population. Concerning a smaller set, a population might be a set, and sample is a subset of population. A sample is a set of data drawn from the population. In order to do some calculation, it is very hard to do the data with the population. For that, we are trying to accumulate, we are trying to convert with some limited number of data. That is what sample, and potentially very large, but less than the population. See, the parameter, a descriptive measure of population is nothing but parameter. A descriptive measure of sample is nothing but statistics. And that is what the issue with statistics. If your sample is not covered the entire population, then it won't give the appropriate results. So the selection of sample is very important. It has to cover the entire boundaries of the population. In such a manner, you need to select the appropriate samples. See, here a set of population and the sample is given. Here the balls, that is red color balls alone detailed, but it won't be practically, it won't be possible. It would be in different properties. See here, the population would might have a different set of colors like red, yellow, or blue. Your sample should cover all these boundaries. Then only your statistical data will be reliable. The population have parameter and sample have statistics. And the statistical inference is the process of making an estimate or prediction or decision about a population based on a sample. See, and what we can infer about the population parameter based on the sample statistics. These things I have detailed in the earlier class itself. The importance of these the prediction or estimation, or it might be a forecasting through various examples like in Kumbh Mela, or it might be a meteorological forecast, or there are many times I explained about these the importance of estimation or prediction. That is what we are doing with these numerical methods. But the thing is, concerning finite element analysis, we are well aware with the known regular geometries and boundary conditions, but we are very hard to find the unknown geometry and unknown boundary condition. That is why we are trying to deal with these type of numerical methods or finite element analysis. See, a collection or a set of individuals or objects or events whose properties are to be analyzed is nothing but population. And the kind is, there are two different kinds are available. One is finite and another one is infinite. And as I detailed earlier, a subset of population is nothing but sample. And there are some other vocabularies related to the statistics is variable, data, experiment, parameter, and statistics. A characteristics about each individual element would be the population, and the value of variable associated with one element of the population, or it might be a population or a sample, is nothing but data. Usually it don't have the plural. We are going to know, we are not going to call it as data. Even for plural also it would be only data. The planned activity whose results yields a set of data would be experiment, a numerical value summarizing all the data of an entire population is nothing but parameter. Numerical value summarizing the sample data is nothing but statistics. And these are some examples. See, a college dean is interested in learning the average age of the faculty. In order to identify the basic, in order to identify the average age, what are the parameters they have to do? See, the population is the age of all the faculty members. A sample is any subset of the population. For example, we might select 10 faculty and determine their age. Through that results, we can that statistics can reveal the information for the population. And the variable that is here, the considered variable is the age, and the data would be the age of the specific faculty member, and data would be the set of values. See, when we are dealing with various age 1, 2, 3, like 45, 36, 37, that is also a data, but it has more than one specific faculty member. And the experiment would be method used to select the age, forming the sample, and determining the actual age of each faculty member based on the questionnaire you are trying to get the data, or based on some other applications. The method which you are adopting to get the data is nothing but experiment, and the parameter of interest, that is the average age of all the faculty, is a parameter. And the parameters, which is the term related to population, and statistics is the term related to sample. And see, when these vocabularies are known, then we can find, we can make the we can do the mathematical calculation, that is what least square regression. And here in engineering, two types of applications are usually encountered, and one is trend analysis, another one is hypothesis testing. The trend analysis, that is predicting values of dependent variable, may include extrapolation beyond data points, or interpolation between the data. What we did in the earlier mathematical technique, we are trying to a set of data were given, and they are asked us to find the sales increase in the year between 1921 1931. That is what interpolation. And even we can do the extrapolation when we have the appropriate mathematical model, or it might be an empirical model. At that time we can do the trend analysis. For that, we are assuming it isn't we are assuming it returns an accurate results. The results of that empirical model would give the resultant value. That is what the hypothesis we are assuming. That is what the hypothesis testing. And see, when we have data, the actual curve, this is what the actual curve. And in order to do the modeling, in order to do the in order to build the mathematics, in order to build the empirical model, the timeline has to be made, and it has to cover all the points. That is what the objective. And these are all the other terminologies and mathematical terms, that the arithmetic mean and standard deviation, variance, coefficient of variance. And this is what the mathematical slope and intercepts. Usually we are already aware about these since our 6th or 7th standard. Y is equal to mx plus c. M is in slope and c is in intercept. That is what rewritten as a naught plus a1x. And even fittest tightline also you studied during your school days. And these are all the accumulation of various derivation and other details about these derivations. A sigma x square plus b sigma x is equal to sigma y, and a sigma x square plus sigma xy is equal to n. That is the basic formulas for fittest tightline. And this is what the derivation of that fittest tightline basic formula. And importantly, the correlation coefficient. This is what introduced by Carl Pearson, and this is the measure of the reliability. When the R is nearer to 1, at that time the predicting ability of your model is good. If it is far away from 1, then the predicting ability will be very less. And similarly, polynomial regression, this is what the derivation of these formulas and the analysis of variance. And for this is what a simple example for least square, and we have some set of data, that is x and y, and we are going to build a mathematical linear mathematical model, and for that we need xi, yi, and x square, and this is what the summation. We have 5 set of data. The last one is not a given set of data, that is what the accumulation. This is what sigma xi, this is what sigma yi, and this is what sigma summation of xi, yi, summation of xi square. And xi, yi, xi, yi, and x bar, y bar. Yes, just a minute. Yes, my Excel is visible. My Siddharthan, my Excel is visible.
Yes, sir. Yes, sir.
Yes, we can do the mathematical model through Excel. We can reduce our see. See, this is what the linear regression model. See, if we have set of data, we can build the mathematical model directly from the Excel. See, insert, and do scatter diagram. Build a scatter diagram, and in that you can have a model. Trend line, and go to the trend line, linear trend line, more option, and in that display equation on chart, display r square value on chart. See, this is what the mathematical model, that is y is equal to 5.4x plus 9.2, and the reliability value is given. Through that, what we can do? Yes, we have, this is what the empirical data. If this is what your x 0, 1, 2, 3, and 4, when what is the y? If our focus is the extrapolation, that is, if when x is 5, what we can do? We can, with the aid of this mathematical, that is empirical model, you can get what is y. If your x is 6, then what is your y? That is what we can do. That is what prediction of forecasting or whatever it might be. So you try with the Excel, and this is what in the similar fashion you can do your quadratic, cubic, and exponential, and moving average, etc., etc. You can do wonders with these Excels. So for doing the prediction or forecasting, we applied the regression model, and apply these values in the formula. You will get your a0 and a1. And the other the rest of the topic is Euler's method, improved Euler method, and modified Euler method. And see, we'll first we'll approach the problems. Once the problem is over, then we will discuss the derivation. We'll try to discuss the derivation. See, Euler's method, yn plus 1 is equal to yn plus f of xn. Do you have any doubts with these regression models? And regression. Do you have any doubts with these regression techniques?
No, sir.
No. Okay. Okay. Fine. Fine. Euler's method. Yn plus 1 is equal to yn plus f of xn comma yn into h, and improved Euler method has some different formula. Y of m plus 1 is equal to ym plus h by 2 into f of xm comma ym plus f of xm plus h ym plus h into f of xm comma ym. And modified Euler method has y of n plus 1 is equal to yn plus h into f of xn plus h by 2 yn plus h by 2 f of xn comma yn. And this is what will solve the problem, that is using improved Euler's method. Apply the appropriate formulas and try to find the results. There are three different formulas are available to find the values in Euler's method. One is Euler's method, improved and modified. Here they are concerned about improved Euler's method, and find y of 0.2 and y of 0.4 from y dash is equal to x plus y. When y of 0 is equal to 1 with h is equal to 0.2. Your interval is equal to 0.2, x naught is equal to 0 and y naught is equal to 1. And this is what the improved Euler's algorithm. And when putting m is equal to 0 in equation 1, let it be the equation 1, and we will get y1 is equal to y naught plus h by 2 into and so on. And here x naught is equal to 0, y naught is equal to 1. F of x naught, x comma y, that is what given, x plus y, h is equal to 0.2. Apply these values, then you will get f of x naught comma y naught. That is what equation number 3. Substituting equation number 3 and 3 in 1, we will get 1 plus 0.1 into 1 plus f of something, that is x naught plus h into y naught plus h. And see, this is what 0 plus 0.2 plus 1 plus 0.2, and you'll get f of 0.2 and 1.2, and try to find the value of f of 0.2 and 1.2, that is x plus y, and you'll get 1.4. And substituting this information, that is 1 plus 0.1 into 1 plus 1.4, and this becomes 2.4, and it then 0.24, then you'll get 1.24. And by putting m is equal to 1, by putting m is equal to 0, we derived y1. By putting m is equal to 1, you will get y2. And we are aware our x1 is equal to 0.1 and our y1 is equal to 1.2, our h is equal to 0.2. In order to apply in some other point, we need this f of x1 and y1, and therefore I am finding earlier, I am finding f of 0.2 and f of 0.2 comma 1.4, and the summation is 1.44. Apply these informations and you'll get the y2 value 1.928, and y of 0.4 is equal to 1.5768. And using improved Euler's method, solve y dash is equal to x plus y plus xy, and y naught is equal to that is y of 0 is equal to 1. Compute y at x is equal to 0.1 by taking h is equal to 0.1. Take the formula, apply the basic information, you'll get f of x naught comma y naught as 1, and then apply in the given formula, you'll get f of 0.1 and 1.1 as 1.3. Therefore, y is equal to y of 0.1 is equal to 1.1155. And using modified Euler method, find the solution of initial value, that is dy by dx is equal to log x plus y. When x is equal to 0, y is 2, at x is equal to 0.2 by assuming h is equal to 0.2. And take the modified Euler method. This is what modified Euler method, modified Euler algorithm. Y of n plus 1 is equal to yn plus h into f of xn plus h by 2, comma yn plus h by 2 into f of xn, comma yn. And apply when n is equal to 0. Not differentiate with modified and improved. We used various suffix, and you remember with that suffix, and don't make confusion with these three different formulas. And our y1 becomes, be conscious, the approach with log and ln is entirely different. And y.2 is equal to 2.0657. And other problem with a modified Euler method, dy by dx is equal to 1 minus y. And this is what modified Euler algorithm. Apply the basic information, you'll get f of x naught y naught. Apply in the formula, you'll get the results. Y of 0.1 is equal to 0.095 and y2, y of 0.2 is equal to 0.1810. And when see there are three different essentially we need to find the value of y of 0.1, 0.2 and 0.3. That is what here when applying n is equal to 0, you will get y of 0.1. When applying n is equal to 1, you will get y of 0.2. Apply when applying n is equal to 2, you will get the results of y of 0.3. And this is what the other problem, that is given that dy by dx is equal to x minus y by x plus y, y of 2 is equal to 1. Compute y of 1.9 by using improved in a problem. They are requiring two different procedures. One is improved and the other one is modified. And you try to solve this particular problem. And any query with these mathematical solutions. So any queries with the solving procedure of Euler's method? Any query? Hope do you don't have any query? And see, this is what the derivation in the Euler method. Whether it is audible for me? For me, whether it is audible?
Yes, sir. It's
Yes, sir.
Yes, just a minute. And this is what about Euler's method. Consider the first order differential equation. Let the equation is dy by dx and some function is given in terms of functions given. Let us solve this differential equation under the condition y of x naught is equal to y naught. The solution of this equation is equation number 1, and which gives the function of x, which may be rewritten as y of y is equal to f of x. Y is equal to f of x. Let this equation might be equation number 2. What we need to do, we are going to build these with a graph. That is xy in xy plane. We are going to do with graph. Since the smooth curve is practically straight for a smaller region, and with that we are going to deal, and with that we are going to derive the Euler's method. Let this might be the given function, that is y is equal to f of x, and we are going to deal with some the minimum portions. You take this is what the y naught. Consider you make a vertical line, and this would be y naught, and you draw the parallel lines as y1 and y2, and the difference, the horizontal distance till y0 line is x naught, and the horizontal distance between y1 and y0 is delta x, and this is what delta x is considered as interval, that is what h. And here we add that till that the point, the vertical point which meets the curve is y naught, and concerning y1, this is what delta y. So my y1 is equal to y naught plus my delta y. In order to find the delta y, what I am trying to do, I am trying to build a triangle. This is what the triangle. In the triangle, tan theta is equal to opposite by adjacent. Delta y divided by adjacent is our delta x. That is what. Therefore, the delta y is equal to delta x into tan theta. When we are considering this is as a line, for a shorter area, for a smaller area, instead of taking the curve, in order to make it as simple, we can make it as line. That is what here taken, and see, this is what written as slope at x naught y naught is equal to dy by dx of 0 is equal to tan theta. Delta y is equal to delta x into and dy by dx. See, at x naught and y naught, slope at x naught and y naught, take this is the point of x naught and y naught. take this is the point as this is the point as x naught y naught. In that point, try to draw the tangent. Try to draw the tangent. This tangent, how we can derive this tangent? This tangent can be obtained from tan theta, right? That is what instead tan theta dy by dx of 0, that is x naught, instead of naught is not 0 here, the point of consideration x naught. Okay, so I am applying this dy by dx instead of tan theta here. Let this equation be equation number 3. So my y1 is equal to y naught plus delta x into we derived the value for y naught. I am applying this delta y in this basic information, basic formula, that is y1. So my y1 is equal to y naught plus delta y. Instead of delta y, I am applying as delta x into dy by dx into dy by dx. Here instead of dy by dx, I am going to apply with f of x naught y naught, and that is what my y1. My y1 is equal to y naught plus h into f of x naught comma y naught. Similarly, when y2 is equal to y1 plus h into f of x1 and y1. So in general, what is yn or yn plus 1? When yn plus 1 is equal to yn plus h into f of xn comma yn. That is what in general formula. See, in general, this is what the Euler method. Any doubts with this derivation? Any doubts here? Any doubts?
No, sir.
Yes. When this derivation is very clear, then we can easily approach, when we can easily understand the modified and the improved Euler method. This is what improved Euler method. See, when we are very clear with this formula, that is yn plus 1 is equal to yn plus, just a minute, yn plus h into f of x and yn, then the improved Euler method. For getting this improved Euler method, dy by dx is equal to f of x comma y. That is y of x naught is equal to y naught, and y1 is equal to y naught plus delta y. And when instead of delta y, what we applied? We applied h into f of x naught comma y naught. And what we are going to do with this improved Euler method, we can, instead the f of x naught y naught, what we can consider it as an average of f of x naught y naught and f of x1 y1. So for delta y, I am going to consider the average f of x naught y naught plus f of x1 y1 divided by 2 into h. Therefore, the h becomes h by 2. Here f of x naught y naught plus f of x1 y1. Instead f of x1 y1, what I can apply from the past derivation, from the past information, I can apply with the f of x naught plus h plus f y naught plus h into f of x naught comma y naught, right? This is what, instead of f of x naught y naught, I am applying the earlier derivation. So this is what my improved Euler's method. Y1 is equal to y naught plus h by 2 into f of x naught y naught plus f of x naught plus h. Instead of y naught plus h, I have applied the basic information. See. So I am trying to convert with the generalized form. Y of m plus 1 is equal to ym plus h by 2 into f of xm comma ym plus f of xm plus 1 ym plus h into f of xm ym. This formula is called improved Euler's formula. Any doubts with improved Euler formula? Any doubts?
No, sir.
Yes. Yes. This is what about modified Euler method. Here are the basic information, that is dy by dx, y, y1 and yn. Here the initial coordinate is f of x naught y naught, and the next coordinate is f of xn comma y1 x1 comma y1. The thing which we modified in improved Euler method, instead of delta y, we considered the average of this two, right? Here f of x naught plus h by 2 comma y naught plus h by 2 into f of x naught y naught, and here the basic slope, that is m is equal to y minus y naught plus we usually read about y1 minus y2 divided by x1 minus x2. Here y minus y naught divided by x minus x star. From this information, what we can get the data for y minus y naught, that is equal to m into x minus x naught, and instead let the x minus x naught, let it be, and instead m, I am going to apply this function, that is function of x naught plus h by 2 comma y naught plus h by 2 into f of x naught y naught. If it is between x naught y naught and x1 y1, and this is what the formula, and when it is concerned about a generalized form, we need to make with some other notation, that is what here written with n. This is what about modified Euler method. See, we need to, along with this, we need to consider some important points. The error in the solution can be reduced by decreasing the step size. When we are decreasing step size, and your error is also reduced, it is directly proportional, and the method will provide error-free solution if the given function is linear. Because in Euler method, we use straight line segment to approximate the solution. This method is referred as the first order method. So the error in one step of the modified Euler is h cube. This is called the local error. There is an accumulation of error from step to step, so that the error over the whole range is h square over h square, and which is called global error. There are two errors. One is modified Euler error, and the other one is local error. The another one is global error. You try to read this with the textbook, and this is what the mathematical model or the formulas for Euler's method, improved Euler method, and modified Euler method. And that's all about the fourth unit, second half, and my portion is over. Any clarification, any doubts? Any doubts? Any clarification with these modified or improved Euler's method?
No, sir.
Yes. Yes, my contents are over. Probably today or tomorrow I'll share these PPTs, and remaining I am expecting you to present from next week.
Sir, the date.
Date already decided, na?
So no, sir. One of us in a group.
Okay, let them. Why you are worrying? You leave her and present your contents. As per the schedule, you present. I'll take care of her, and I'll give some other slot for presenting. And present. Go ahead with the earlier schedule. Let it be okay, Siddharthan. Siddharthan, are you clear? Your doubts cleared?
Yes, sir.
Okay, we will meet Monday 10:30. Be prepared for your presentation. Thank you, Ananda.